everyone. Today we start with the senior design and research presentations. And first online is Michael Bryant. So let me tell you a little bit about him. Michael Bryant is a candidate for the Bachelor of Science degree in both general engineering and physics. He has worked several REUs in the past couple of years. In the summer of 2010, he works at Harvard on a project where he was trying to design and fabricate and test something called paper-based micro-electromechanical systems, or MEMS. He continued with that work in summer of 2011, and the primary emphasis at the time was to optimize a paper-based MEMS 3-axis accelerometer. So there's a patent pending on this work, currently at Harvard. In the summer of 2012, he worked at the University of Maryland, College Park on a project which was concerned with micro-robotics.
Just programming, helping him, my coordinator in.
He's been a lab instructor for Eastern Nazarene College in the last 3 years or so. So today he'll be speaking about some of the work he's been doing on earthquake prediction, and the title of his talk is Analyzing Anomalies in the Ionosphere Above Haiti Surrounding the 2010 Earthquake. So, go on.
Thank you. Thank you all for coming. My project focuses on the 2010 Haiti earthquake. So to begin, first we need to understand a little bit about the basics of earthquakes. I'm sure most of you are familiar with plate tectonics. Basically, the Earth's crust is made up of these tectonic plates that are moving around, and on the border of two plates, you can have various types of motion, but a problem arises when one of the plates gets stuck, and then when it releases, it kind of gets a more sudden movement, and that's what causes earthquakes. So in order to get the actual electron density, there was this Demeter satellite that was orbiting above Haiti around the time of the earthquake. And this satellite was carrying various scientific equipment. Primarily, what I'm interested in is this ISL probe, which measures electron density, which of course is really good. And then the model that we use is called the Parameterized Ionospheric Model, otherwise known as PIM, which is a physics-based global ionospheric model that takes into account the energy coming from the sun, otherwise known as the solar flux, the state of the Earth's magnetic field, the amount of solar activity, or the sunspot number, and the time of the year, because there are seasonal variations in the ionosphere. So this model, we can look at what it predicts for the electron densities leading up to the earthquake. So this graph right here is a graph of electron density versus latitude. And here this green line represents Haiti. And so this is an ensemble of measurements, or of predictions, that this model creates for this time frame, which is approximately 4 months before the earthquake. So I'd like to point out several key features of this graph. Over here on the left, we see these humps in the electron density, possibly one here. But between about 20 and 60 degrees latitude, it remains fairly flat. And then if we look at the month leading up to the earthquake, same kind of thing. You see these humps here, and then it gets flat over here. The month right after the earthquake, it's the same story. It gets interesting when we look at the actual data that we got from the Demeter satellite. Again, this is an ensemble of data taken over the course of this time frame here. As predicted, we get these humps over here on the left. However, over here on the right, about between 20 and 60 degrees, the model predicted it to be flat. However, we see this hump starting to form.